All right, guys. Are there questions on the homework before we start the lesson today? Any question over the homework assignment?
If you were here Friday?
Yes. Okay.
We got assassinated.
Glad she was able to help out.
Yeah.
She explained it really well.
I'm glad. Yeah, because the one, I think the question you had earlier, the only ones you had to actually name were 3 through 5. The rest were just describing the transformation. Now, what we're doing today is applying transformations. So instead of just identifying, we're actually going to apply the transformations to the functions. Now, the first ones we're going to look at and the first transformations we're going to apply are the translations, vertical and horizontal. And these two equations here are going to be very helpful in applying the transformations to the function. Now, I'm not going to expect y'all to memorize these and have them all set down, and especially on the test, I would write them out and have them to look back on. Because when we do these translations, up, down, left, to right, our reflections, our vertical stretch, vertical shrink, horizontal stretch and shrink, having these are going to be very helpful when we apply the functions, apply these transformations to the functions. Now, we can look deeper into the definitions, but I think it's going to be better if we actually just look at examples of them and see how this works and see how this applies, more than just staring at the definition. So, we're given a function f of x is 2x plus 1. Now, for these main ones here, we're looking at vertical and horizontal translations. Now, our vertical, f of x plus k, is our up and down. Our horizontal, our left and right, is our f of x minus h. So looking at this first one here, we want to write a function g, whose graph is a translation 3 units down of the graph of f. So would we use the equation with h or the equation with k? Because we're going
Down. Okay, so it's
k. Yeah, so we're going to use f of x plus k. Because f of x plus k is our translation up or down. And we're going to move it the amount that is given to us, and we'll define by k. So this is what we want to start off with. Now, they told us to name it g of x, name a function g, whose graph is a translation 3 units down of the graph f. So we'll call the new function g of x. Now, the only reason we use g of x, or h of x is to name a different function. That way, when we're specifying or talking about them, we are not getting confused which one we're actually talking about. We can distinguish them one from the other. Now, any questions on this so far? Now we're going to input some information in. How far are we moving the function up or down? 3. Is it going to be positive or negative? Because which direction are we going? Up or down? Down. So since we're going down, it would be? Because down is our negative direction, up is positive. Right is positive, left is negative. Any questions on this so far? So we can't do x minus 3 inside the parentheses, because that would be talking about a left and right movement. Because if it's, yes, we could have done that, yes. Yeah, so the question is kind of, could we have just, instead of putting it this way, this is the exact same as saying this here. Because we could have put just minus 3, yes, instead of doing plus negative 3. Either one of these works. Now our next spot is we have to apply the function f of x. Since we still just have f of x, Well, it told us f of x is what? 2x plus 1. So I can replace f of x with its function minus 3. Now at this point here, we can drop the parentheses, which will just tell us that we have 2x plus 1 minus 3. Do we have any like terms? 1 and 3, we can combine those, telling us that g of x is almost minus 2. 2x minus 2. And that's it. So the biggest thing with these here is just kind of starting out with the correct one, plugging in our information, and simplifying. Questions on any of this here? Any questions on any of these so far? We ready for the next one? Now I'm rewriting the function back out. You do not have to, mainly because my screen does not show the original function anymore, but your paper still does. You can still see the function without having to scroll back up. So I'll do that throughout the year. Those of you who had me last year, if we had to scroll down too far, I'll rewrite the function out so we can see it and not have to move the screen up and down. Now, this time we want to write a function h whose graph is a translation 2 units to the left of the graph of f. So which one are you going to use this time? Horizontal, which is our f of x minus h. Because if we're going left or right, we're going to use x minus h. Now the question is, what is our value of h going to be? -2 because we're going where? Left 2. We are indeed going left 2, so the value of h would be -2. Exactly. It would indeed make it a positive because we don't normally leave a negative and a minus next to each other, 2 negatives next to each other. Does a negative and negative make a plus? And if you remember, huh? Yes. So it's still going left 2, but remember when we talked about looking at the translations left and right, it's always the opposite of what we think. Because again, it is left, but it looks inside the parentheses. It looks right, yeah. Questions on these so far? Now, our original function was f of x, and it gave us 2x plus 1. Do we have f of x anymore? We have f of x plus 2. We replace the x with what? X plus 2. So we replace this x with x plus 2, which means every x in the function has to be replaced with x plus 2. So we'll still have this first 2. But we don't. For the most part, yes. No, you're good. We'd have x plus 2 plus 1. Because in the original function where there was an x, it is being replaced with what's inside the parentheses, x plus 2. Questions on how we got to this point here? Well, now we need to simplify, so we'll distribute the 2. Telling us h of x, 2 times x is 2x. 2 times 2 is plus, yes. And when we combine like terms, 4 plus 1 is giving us this here. Any questions on any of this here so far? We ready for the next one? They gave us a different function, 4x minus 9. Write a function g whose graph is a translation 5 units up. So which one would we use, f of x minus h or f of x plus k? Which would be? Mm-hmm. And what is our value of k? 5. Would it be positive or negative? Positive, because we're going up. We're going up, so it's going to be plus 5. Now, unlike the last one, did we do anything to f of x? The function specifically, do we need to change anything about the function? No, we didn't have anything. We just still have f of x. So that means I can just replace f of x with its function. So we'd have 4x minus 9 plus 5. We can drop the parentheses and then simplify, telling us g of x is equal to 4x. Then what? Yes. And that's it. Questions on any of this here? We feel pretty good with up and down. Let's look left to right. Write a function h whose graph is a translation 1 unit to the right of the function f. So this would be our f of, yes, f of x minus h, because our f of x minus h moves it to the left or to the, now what is our value of h? Positive 1, because we're moving right 1, yes? Yes. Because that is the original function. Yeah, no, I just put it out to there to the side so we do have it as a reference point. Thank you for the question, though. Okay. Any other questions on how we set this one up so far? So inside the parentheses, we have x minus 1, so we have changed it from f of x to f of x minus 1, which means every x in f of x has to change to x minus 1, which tells us that we have h of x is equal to 4. Originally it was times x, now it's times x minus 1 minus 9. We would indeed distribute the 4. Which would give us 4x minus 4 minus 9, which would be 4x minus 13. And that is it. Any questions on any of these here? Are we starting to feel a little more comfortable with this? Because I feel like when we use these here, the f of x minus h and f of x plus k, it really helps us be able to keep everything straight in how it's being applied. Now this next one, f of x equals 3x, translates 5 units up. It didn't tell us what to write it as, but we can pick. It doesn't matter. We can pick g of x, just a way to define it. Because I can pick q of x, I can pick L of x. It doesn't. We can pick anything we want.
Oh.
F of x plus k, because we're moving up or down. Now, what is our value of k? 5, and it would be positive, because we're going up. Now we just need to replace f of x with its function, which would be And do we really need the parentheses for this one? No, because there's nothing really in front of it or behind it. It wouldn't be wrong if we keep it. It's just we would need to drop the parentheses. And since 3x and 5 are not like terms, that's it, as far as we can go. They will have the same variables.
Like the same factors.
Yeah, 4 and 5, constant terms, linear terms. F of x equals the absolute value of x minus 3. Translate 4 units to the right. So we do g of x, and it would be an absolute value function. Now, which one would we use? Horizontal, which is our f of and our h value is 4. Specifically, it would be positive 4. So we have x minus 4. So not so much the f, but the x in our original function with x minus 4. So every x in this function would be replaced with x minus 4. So we'd have the absolute value of x minus 4 minus 3. Yes. But we don't necessarily need them there because there's nothing else that's going to affect it. So we can leave it as the absolute value of x minus 4 minus 3. Any questions on any of our translations so far, up, down, left, right? Well, I kind of gave it away. Our next one is reflection. And there's two ways we can reflect a function, across the x or across the y. Now we could reflect it across a line away from either one of these, but we're mainly just going to look at across the x and y axis. Now if it's across the x axis, we're looking at negative f of x. If it's across the y-axis, it's f of negative x. So again, these two things here are going to be important. And we're going to treat this just like we did with our translations up, down, left, right. We're going to start them the same way. We ready for this next part? Write a function g of x. whose graph is a reflection in the x-axis of the graph f of x. So reflections, we have two. We have negative f of x, and we have f of negative x. Which one do we want to use for this one here? Because negative f of x is across the, and f of negative x is across the y-axis. So here we're going to have negative f of x. So we still have f of x, yes? We just put a negative in front, which means we're going to replace f of x with its function, just have a negative out front. So we'll still have the absolute value of x plus 3 plus 1. Negative parentheses, absolute value of x plus 3 plus 1. Well, the next thing we need to do is distribute the negative. Now, something interesting with absolute values, we cannot multiply the negative through it. We can't multiply the negative by the x inside the absolute values or the 3. What we end up doing is just putting it out front. Same thing's true with a number. If we did 2 and had the absolute values in parentheses, it's just going to be the 2 in front. So we'll have negative absolute value of x plus 3. But we also have to distribute that negative to our positive 1, which is going to make it what? Negative 1. And that's as far as it goes. Questions on any of this here so far? What do you think? Reflections are a little bit easier. I mean, there are a few less steps, but we're following the same type pattern. Any questions on part A before we look at part B? Write a function whose graph is a reflection in the y-axis. So with x plus 3 plus 1, I believe, is our original function. Now we're looking at a reflection in the y-axis. So because we're doing y-axis, we'll have f of negative x. Well, unlike the x-axis, we have now replaced the x in the function with negative x, which means over here I've got to replace this x with, which will tell us h of x is equal to the absolute value of negative x plus 3 plus 1. If there had been a number in front of the x, we would have to multiply it, but since there's not, this just becomes negative x plus 3 inside the absolute value bars plus 1. That's it. Questions on any of this here? We good with this here so far? Yes? It might be helpful to look at another reflection. Let f of x equal the absolute value of x minus 5 minus 4. We want to reflect it in the x-axis. This time they started off using h first, but it really doesn't matter. So we have h of x equals negative f of x, because when we were correct for reflected across the x-axis, we use negative f of x. since we didn't do anything to the function f of x, because we just put a negative out front, we can just replace f of x with its function and kind of put that negative out front. We will still need to distribute it through, but we do have this set up here. Questions at this point so far? So, right, we drop the parentheses and distribute it through. Now, the negative won't go into the absolute values, but it will go out front, telling us that we have negative absolute value of x minus 5. And it would be plus 4. Because our negative times negative 4 will make it positive 4. So we get this here. Questions on this so far? Now, we didn't do this on the rest of them, but clear. Math of x minus, what was it, 5? Minus 4. So this is our original absolute value function. This is what we started with. Now we wanted to reflect it across the x-axis. Well, our x-axis, we have that straight line there. So it should be a mirror image across it. And what we said the new one was negative math absolute value of x minus 5. I need the 5. Plus 4. Graph. Does it look like a mirror image across the x-axis? Yeah. All right. Get ready for the next one. This time we decided to name this one g of x, whose reflection in the y-axis, which means we're using what? So this time we're replacing every x in f of x with negative x. So we'd have the absolute value of x minus 5 minus 4. So we can drop the parentheses. If we need to, yes. But here, we don't, because it's just the negative x is the only thing that has it, or anything that's changed. Now, if there had been, say, instead of having x minus 5 inside the absolute values, if it had been, say, 2x minus 5, then we'd have to multiply the negative x by the 2 to simplify. Questions on this here? Now, in our graph, we're looking at the blue one, because that's the one we started with, and we're going to reflect it across our y-axis, our line straight up and down, is what we should see. So we'll do this here. So math, absolute value, negative x minus 5 minus 4. So that does look like a reflection across the y-axis of the blue. Yes? Flips it. Any questions on any of this here so far? We feel pretty comfortable with everything so far? Well, let's look at this one here. Now, it doesn't tell us what to call this one. We'll call it g of x. So we have a reflection in the x-axis. So which one would we use? Negative f of x. And again, with f of x, we didn't change anything with our f of x. We're not having to replace x with anything, so we can just put our normal function back down. And since we do have a negative outside those parentheses, we do have to distribute it. And we distribute the negative. We multiply the negative by the negative absolute value. That negative and negative makes a. So we just have the absolute value of. And our negative times the negative 1 makes it plus 1. And that is it. We will, yes. So we'll get to that tomorrow. This is the last one we'll do together because we're actually 2 ahead of, I think, last hour and some of the other hours. But that's fine. G of x is going to be a reflection of the y-axis. So this would be what? F of? Now this time we do have to plug something in because we changed f of x to f of negative x. So every x in the function has to be replaced with negative x. So we'd have 1/2 parentheses. Now this time we do have to do some multiplying together because up to this point it had just been negative x by itself. There hadn't been anything with it. But this time we do have to multiply the 1/2 and the negative x. We have to multiply these two together.
So is it just
Plus 1. Yep, that's it. Huh? Not today. But again, the biggest thing I would say with any of these are the setups are f of x minus h or f of x plus k, or negative f of x, f of negative x. Having those down and looking back on those and referring to which one we need based off what we're doing is going to be key. I'm not expecting you to memorize those, and especially on the test, I would have them written on the review sheet somewhere so that you can refer back to them. If I don't have them, you should.